All right, welcome back to Clever Minds, still on quadratics. And in this section, we'll be looking at examples on maximum and minimum values of a quadratic equation. Right? Good. So, given that y equals 2 minus 3x minus 4x squared, find the maximum value of y and the value of x at which y is maximum. So, let's see how to go about that. Here is the solution. Take that. So let's see the solution. So now we have y equals to what? 2 minus 3x minus 4x squared, which can also be written as what? Minus 4x squared minus 3x plus 2. Right? Good. So the next thing for us to do is to solve by method of completing the square. So let's see. Negative 4, open bracket, x squared plus 3 over 4x. Do you understand that? I'll explain. Negative 4 multiplies x squared, you get this. Then negative 4 multiplies 3 over 4x, you get minus 3x. Do you understand? That's simple factorization. So now, let's move on to the next step. We have negative 4, open bracket. What's the coefficient of x? 3 over 4. You come here, divide the coefficient of x by 2. That is, you half the coefficient of x. That gives us 3 over 8. That's the result. Now, the next thing for us to do is to square the result. That gives us 9 over what? 64. Then 9 over 64 will be added to this expression, x squared plus 3 over 4x. And that gives us x squared plus 3 over 4x plus what? 9 over, take that again, so let's not look at this a, 9 over 64. Then, now, this is already a perfect square, but it does not look like this expression. So one thing I have to do is to include minus 9 over 64. Yes, to make it look like this expression. Is a mathematical technique in solving, completing the square method. Right? Good. So, which means plus 2. So that gives us the room to negate 4 and 64 here. So see what we are going to do to that. So negative 4, I'll still repeat this. I'll repeat it. X squared plus 3 over 4x plus 9 over 64. Then I close the bracket, meaning I'm not using the negative 4 to multiply any of these expression or any of this term in the expression, but I'll use it, negative 4, to multiply minus 9 over 64, just to reduce it to what? Plus 9 over what? 16. Do you understand? Good. Then plus 2. So now this, remember, this is a perfect square and it's coming from here. This is it here. So I'll just write negative 4 into x, this x squared, plus 3 over 8 squared. So I'll just write 3 over 8. Then all squared. Make it a perfect square. If you want to try that, just expand x plus 3 over 8 all squared. You get back this expression, which will be correct. Right? Good. So plus, if you take the addition of this and this, you get 41 over what? 16. Yes. By finding the LCM. So now, we are almost there. So remember, you can see that we have negative 4 as our value for A. That means our A, this is negative 4, determines the maximum value of y. So A is what? Actually less than 0, because A is equal to negative 4. Right? Can you see that? Good. So we can conclude that the value of x, or let's say we can conclude that when the value of x, when y is at maximum, is this. let's come there. The value of x, remember, just equate the expression inside the bracket to 0. So I'm just going to write x plus 3 over 8 equals 0. And that gives us x equals to what? Negative 3 over 8. So this is the value of x at which y is at what? Maximum, right? So now, remember, when x plus 3 is equal to 0, what does that tell us? Let's come here. Negative 4 and x plus 3 is 0, all squared, plus what? 41 over 16. What's that telling us? This is 0 plus what? 41 over what? 16. And that gives us what? 41 over 16. So the value of what? X at which y is at maximum is negative 3 over 8, and y is at maximum at what? 41 over 16. Y maximum equals 41 over what? 16. So remember what the question says. Given this equation, find the maximum value of y. This is the maximum value of y, 41 over 16. And the value of x at which y is at maximum is maximum. So the value of x at which y is 41 over 16 is, so this again is called the line of symmetry. The line of symmetry. So it's actually a line, and this is the maximum value of what? Y maximum. So we have come to the end of this question. So once again, this class is brought to you by Clever Minds. Thank you for your time, and you have a great day.